Growing up, I thought that I would be an artist. I spent all of my days drawing, and that all changed the day that I got my first computer. And the web ended up being a great mix between art and coding for me. I'm a front-end engineer at Box, and I joined to help Box scale the front-end architecture. One of the big problems with front-end right now has to do with scalability, and that, I think, traces back to architectural problems. JavaScript, CSS, HTML is kind of a wide open area where there's not a lot of built-in structure. There's, I think, a very interesting thing that goes on in the JavaScript world where jQuery has become so prevalent. jQuery is where you start, it's not where you end. And the more that people realize that, the easier their jobs are going to be when they get into really large web applications with a lot of code. My name is Nicholas Zakas. I'm a staff software engineer at Box, and I'm a member of the ACM. Yeah, I think starting in elementary school, I just found myself really drawn to art, and I would sketch things all the time. I always had a little drawing pad with me, so if I got bored, I would just look around and draw whatever I would see. I can remember as a child just being bored and saying, well, I'll just draw that table. It gave me a lot of pleasure. I'm a very visual person, and that really excited me a lot as a child. And when I got into middle school was when I started getting into computers. So I sent my first email as a 6th grader at school, and I started playing around on an Apple IIe, writing basic programming. And I thought, wow, that was really cool. And then one day I discovered that you could write code and produce graphics on the computer. And up until that point, I had been pretty sure that I wanted to do art as a career. And seeing the computer generate art was like a light bulb going off in my head and saying, wow, that's pretty amazing. I can type some commands and pictures show up. And it really didn't set in completely until I saw a web page for the first time. And then I was hooked. And that was towards the end of my high school years. I thought that was the most fascinating thing I had seen at that point in time. So front-end engineering has become very important because of the expectations that have been set for interactions on the web. I think initially when there was just HTML and a little bit of CSS, the expectations were fairly low. It was that you were going to go and read some content and maybe link off to another page and potentially see a picture along the way. But now, because we have so many dynamic, interactive, rich user experiences created on the web, there's an expectation that that is what the web is about. And so with that expectation comes businesses coming in and saying, we want to do that. We want to be like that. We want it to be fast and slick and cool and have animations and transitions and all kinds of things. And so the business actually starts to put pressure on, okay, we need to do more interesting things in our UI because we know that it's possible. And in order for us to compete, we need to be able to have that same sort of experience because the bar has been raised. It's been a long time since apps like Gmail and Google Maps first came out and showed us how you can do these really cool web interfaces with just HTML, CSS, and JavaScript, and now that is the standard bearer for everybody. One of the big problems with front-end right now has to do with scalability, and that, I think, traces back to architectural problems. So JavaScript, CSS, HTML is kind of a wide open area where there's not a lot of built-in structure telling you how you should set things up. And so if you're coming from a more traditional language like Java, where you have conventions around packages, how folders should be named, and how files are set up, that can be really confusing because you can set it up any way that you want, but what is the right way to do that? And is there a language that you're familiar with that you try to mimic, or are you coming up with something completely new? And so that's where a lot of companies now are running into trouble, where they have just these massive amounts of JavaScript and CSS, and it becomes very fragile, very hard to maintain, and people are afraid to make changes. And so coming up with solutions to that problem is something that is just really starting to happen in the past couple of years. We're starting to see a lot more focus and research being done on both architecture for JavaScript and for CSS. So in the realm of JavaScript, people have been looking at things like dependency management, where you have tools like Bower that helps you as a developer install and keep track of the dependencies that you have. There's also require.js, which is trying to put some logical structure around smaller parts of JavaScript that also helps you with dependency management, but makes you think a little bit more about how can I separate things into smaller pieces. And then you have the MVC movement, which was spearheaded by Backbone, and starting to think about the front end as we have some data, and then we have a view that's representing that data. And that view may dynamically change at some point, and so we want to have some structure to do that. So there's a lot that's happening on the JavaScript side of things. On the CSS side of things, we have similar architectural discussions that are happening. So there's Nicole Sullivan's OOCSS approach, which is similar to the JavaScript architecture idea that you create a bunch of very small pieces that you can combine together to create the final thing that you want. So instead of trying to come up with a unique class for absolutely everything that you have, you come up with a bunch of smaller classes that describe just pieces of what you eventually want, and you can mix and match those together. There's also approaches like Jonathan Snook's Mac CSS, which arranges things into layers and how you should think about things. So do you start with your typography, and what are the properties that belong with typography, and how do you keep those separate from the properties that belong with layout? And how do you keep that separate from the properties that deal with color and background color and all of like the visual niceties that you would consider a theme? So there's a lot of work that's been going on the past couple of years, and I think that it will only continue now that more and more companies are getting into this. We have a really complicated front end, and we need to make sure that we can continue to use it without just shooting ourselves in the foot at every turn. I'm a front-end engineer at Box, and I joined to help Box scale the front-end architecture. As with a lot of companies who have grown from small to large, the code started out as pretty small and very easy to handle, and over the years, as we kept growing, kept adding more features, we started to add more code, and things started to get a little bit more complicated. So what I'm trying to do is evolve the front-end architecture in such a way that it sets us up for the next group of really cool and interesting features to be implemented, and also just provide some structure so that things that we don't even know that we're going to build are going to be possible to be built in our app without much additional change. So part of what I'm doing with the front-end architecture is first and foremost trying to make sure that everything has a defined place in the architecture. I think it's really important that when somebody goes to add something or when they need to modify something, that they know exactly where to go for that. And that's a problem that I see in a lot of large web apps, is that when people need to add something, they're not entirely sure where to start. So we've defined some clear buckets of functionality where when you need to add something new, you can say, which of these buckets does this belong to? And then depending on which bucket it ends up in, there are specific patterns for you to follow. And I find that that helps people just get up and running a lot easier, and also makes it easier to maintain that code going forward. In addition, we're taking a hard look at the code that already exists and starting to break out large files into a bunch of smaller files and objects. And what that's doing is allowing us to both review the code that we already have and find patterns of maybe methods that were in two different places that really should be part of the same thing, and combine those and ultimately create a lot of very small pieces from the larger pieces that we had. And that makes it a lot easier to do things like write unit tests for those small pieces, and even evaluate if those small pieces are necessary at all or if we can remove them. And because they're now a much smaller piece, it's a lot easier to remove that from the code base if we need to. And so we're really just trying to create a better understanding of what functionality lives where in the architecture so that we all feel more comfortable working with the code and knowing where to go for certain types of problems. There's, I think, a very interesting thing that goes on in the JavaScript world where jQuery has become so prevalent that a lot of people start and end with jQuery as JavaScript. And that's okay for certain types of things. I think certainly when you're doing some quick prototyping, or if you're somebody who maybe doesn't have a strong programming background, jQuery is a great way to get up and running very quickly. What I generally find with companies that are creating larger web applications, they start out with jQuery, and very quickly they end up with a bunch of spaghetti code. And that's not necessarily a problem of jQuery. It's more a problem of how people use jQuery on an ongoing basis. And that has to do with understanding where jQuery or any other JavaScript library exists in your architecture. Now, libraries like jQuery, Dojo, and YUI provide a very, very important layer to your architecture, and that's a base layer that abstracts away browser differences. Because as a web app developer, you don't want to have to worry about all of the browser differences all of the time, especially as it relates to really low-level functionality like working with events or working with the DOM. What you want to spend most of your time on is creating your web app and not worrying so much about how browser A acts versus browser B. And so jQuery and those other libraries fill that role really well. Where things start to get complicated is when you want to do more than that, is how do you organize your front end? How do you, say, use widgets? How do you create modular functionality? And jQuery makes it so easy to very quickly get a reference to an element and start working with it that people tend to do that all the time. And that leads you to giant declarative pieces of code that are not very modular and have strict dependencies on one another and make it very hard to have a lot of people working in the same code base. So understanding that things like jQuery and Backbone have a very specific part of your architecture in mind helps to make that problem a little bit easier to deal with. You say that, okay, we're going to use jQuery as our browser abstraction layer. But then we need some structure on top of that. We need some way to group functionality together. And maybe that is Backbone. You use MVC on top of jQuery. And so you're actually writing most of your code in Backbone and with a few references to jQuery. Or maybe you end up creating your own architecture on top of jQuery or on top of jQuery and Backbone to deal with higher level things. I think the overall lesson is that jQuery is where you start, it's not where you end. And the more that people realize that, the easier their jobs are going to be when they get into really large web applications with a lot of code. Yeah, I think the best advice that I would give to anyone is that your career is only as limited as you make it. And the way to unlock your potential is to continue learning and continue talking to people. I think looking back on my career, I realized that there were so many people that helped me out along the way. I was very fortunate to have a number of really great mentors at the various jobs that I worked at that allowed me to grow and challenged me to continue to improve and gave me really good, honest feedback and criticism about what I could be doing better, how I could be dealing with people better, how I could be working with code better. And I've always really appreciated that and taken it to heart. And I think that everybody should really just stop and think about who are the people around you that you can learn the most from, and really having an attitude of humility as you're going through your career and thinking that you don't know everything and there is somebody out there who knows more than you. And if you can have a conversation with them, maybe you can learn a little bit. And if you go to conferences, maybe you can meet people with different perspectives. And if you have a senior member on your team, maybe you can pick their brain about interesting problems that you've encountered. And just always be looking to learn, always be looking for teachers that can help you learn. I think as long as you're working for somebody else, there's always going to be pressure to get things done at a certain period of time. There's going to be deadlines that are either self-imposed or imposed because of some deal that has been struck. And so the pressure then comes down on the software engineer to actually implement that. And there's a tendency then to get caught up in, well, how can I get this done as quickly as possible? Because I think that's what people want. And in reality, what people want is for you to create value for the company. And you do that by creating code that doesn't just work for the next week, but code that continues to work much longer after you've finished writing it. And so would you rather spend a little bit of time now to get something done and then continue to spend time fixing bugs over the next 4 or 5 months? Or is it worth spending a little bit more time right now and actually having that code be done? And that's something that it has to be dealt with on a case-by-case basis. But most of the time, you're better off taking a little bit more time to plan out what you're doing and then start coding so that what you're building upon is a better foundation. If you start to code without doing any planning, it's almost guaranteed that there are going to be unanticipated problems down the road.